It is the Gulf of Maine Marine Education Association. It's our annual meeting. And I'd like to welcome you all. It is just 6:01. We have our agenda here. First, we'll have our Board of Directors meeting, which is short, and then we will move on to a meeting of the whole membership. And then we have our guest presenter after that. So I would like to, I'm Deb DeVegan. I'm the current president of Gommea, and I'd like to call to order the annual meeting. And if board members could just wave their hands. I believe there are at least 8 of us here, which lets us have a quorum. Our first order of business is to approve our minutes from September. Is there a motion to accept the September minutes as written?
I'll do it, Tara.
Is there a second?
I'll second. It's Jen.
Thanks, Jen. Any discussion? Okay. Our second order of business is taking a look at our proposed board of directors slate here. Darren Cleavesy is filling a vacant, is on the slate as filling a vacant slot that was ending at the end of 2022. And I would like to ask if there is a motion from our board of directors to accept this nomination slate.
I'll make a motion. It's Mike.
Thanks, Mike.
I'll second it. It's Tara.
Thank you, Tara. Any discussion?
Welcome, Darren.
Thank you. I'm excited.
Wonderful. I believe that's all of business that we have for the board of directors. Is there any other board of directors business that anybody would like to bring up? Okay, is there a motion to adjourn the board of directors meeting?
I'll move. It's Jen.
Thanks, Jen. Is there a second?
I'll second. It's Tara. I'm like,
Thanks, Tara.
I'm on a roll tonight.
You're on a roll. Wonderful. Well, welcome everyone. I'd like to call to order the annual meeting of the membership of Gommea. We have a few items tonight. The first is looking at the slate of directors and recognizing the officers who are in 2 terms. Then we'll have a few words about some past events and updates, a brief preview of some upcoming events, and an opening for other business before we adjourn our annual meeting of the membership and welcome our guest presenter. So thank you all for being here. Gommea is a membership-based organization. So without your membership, we are a shadow of what we would be. So we need you all here. So thank you for being able to attend. The first item is the proposed board of directors slate, as was shown a moment ago. Again, the new addition is Darren Cleavesy, visitor program coordinator at the Seacoast Science Center, has agreed and been supported by the board of directors to join, finishing up a term which ends in 2022. And we hope that she will stay with us on the board. And renewing board members are denoted with 2 asterisks. Is there anybody else who would be interested in joining the board of directors of Gommea at this time? You are welcome to speak up. Okay, could someone make a motion to accept this slate of directors as presented? And this can be anyone on the meeting because you are all members by being present.
I'll make a motion to accept the slate of officers, or directors. This is Deb
Thank you.
Sandler.
Thank you, Deb. Is there a second?
Second.
Yeah. Thank you, Anne. Wonderful. Well, welcome, Darren, and thank you, everybody, for all of your dedication and service to Gommea and Gommea's mission. The next up, I just wanted to recognize the board officers. These are 2-year terms, so none of these are changing. Next time we have our annual meeting, Julie Taylor will take the role of president, and thank you to everybody putting in extra time. I also wanted to recognize officers who are stepping off the board, which this time around is Mike Doherty, who joined us when he was at Seacoast Science Center and has since begun and then completed his graduate work. So thank you very much, Mike, for all of your time and effort, and we wish you the best. Thank you, Mike.
Thanks. Thank you.
You can still come to the whale watches, Mike.
Yeah, maybe I'll do that. Yeah.
Great. Are most welcome, always, always. I wanted to put this slide up. We have a robust group of business sponsors or business members, and I wanted to recognize all that they do in just helping connect people to the Gulf of Maine through various different venues. There's a wide range of items that folks do. And I wanted to invite Jen from Blue Ocean Society or Tara to talk about the UNH Discovery Day, or Cassie to talk about our NEOSEC Summit that happened this summer, just to give a couple words. Jen?
Sure. Thanks, Deb. So on Friday, October 22nd at Blue Ocean Society, we held our annual Blue Ocean Symposium, which was sponsored by Gommea. So thank you guys, and the New Hampshire Coastal Program. We had a variety of speakers who talked about lots of different things, including whales, sharks, marine debris, and how best to reach your audience. We had about 90 people registered, and more have watched it online, and the symposium recordings are still available online. So you can go to our website, and in just a moment, I'll put the link in the chat. You can see what the presentations are, and you can sign up to get a link to the presentations, and we have individual recordings, so you can watch whichever ones you want. So I'll put that link in the chat box in just a moment. I'm also our current membership chair, and I also just wanted to echo what Deb said, thanking you guys for joining Gommea and recognizing all our new and renewing members. Gommea is a success because of you, and we can make it even more successful if we have more members. So please help us continue to spread the word and build this organization so we can have even more events like this one. Thanks.
Thanks, Jen. Tara, did you want to say anything?
We recently, actually Monday, I think, finished our Ocean Discovery Challenge, which was a virtual scavenger hunt that we ran through the Goose Chase platform. And it was really fun. It was a good, we normally invite thousands of kids to UNH, and we can't really do that this year. So this was a really fun alternative. So we're still just going to do the debrief, but I'm happy to share our findings with everybody in Gommea once we kind of have a better understanding of it. So maybe next meeting or so. But it was, if anybody has interest in running a virtual scavenger hunt type thing with their organization, I'm happy to share how we found it.
Wonderful. Thanks, Tara. And Cassie, do you want to say a few words about the Ocean Literacy Summit?
Sure. So the New England Ocean Science Education Collaborative is a unique group here in New England. And every other year they have an Ocean Literacy Summit. As with everything else this year, it was moved virtual and held on November 10th with in-person field trips happening on the 11th. It was through the Whova platform, and we had over 91 people attending on that. The ocean literacy principle this year we focused on was on number 4, the ocean makes Earth habitable. It's really hard to say, but I really enjoyed it. We had some great speakers and keynote learning about the deep ocean and our connection to it. And Gommea was also a sponsor for that.
Wonderful. Thank you. on this slide of business members, I just wanted to note the most recent addition was the Children's Museum and Theater of Maine, which has a whole set of aquarium tanks in there, which they moved spaces in the past year, and that was wonderful for me to discover that. So thanks to everyone. Upcoming and current items and events. This PDF will be available online as well, which is why I put all the URLs there. First up was a note about 2020 NMEA, so the National Marine Education Association. If anybody's not familiar, that's our umbrella, our national organization. We are. Tara?
So maybe we can see everybody in person at Hofstra University in Long Island this July. It is going to be a hybrid event. So they are actually going to be offering both virtual ways to present and to view sessions, or you can go in person. And they're going to have dorm opportunities as well there. Their schedule is going to allow for a lot of opportunity for networking and sightseeing and things like that. They've got some really fun field trips and things like that they're setting up. So it looks to be, I think it'll be a really fun chance for people to kind of get back together again and see each other. So more information will be coming out about that kind of in January, I would say. So keep an eye out.
Thank you. I don't have a separate page for the newsletter, but thank you to folks who have been sending in items of interest to the newsletter. Keep those coming. And then next slide was the climate initiative. So our board member who's on the climate initiative board is not here this evening, but there is a new art challenge called Title Shift Contest. And it's a search for young artists emerging in New England who are looking at how to express sustainability, particularly with respect to climate change and ocean issues. One thing that's unique about this particular challenge is that it has two age categories. One is 14 to 18, and then the older age group, 19 to 22, is one that I have not seen so much before. There are cash prizes. There's an amazing suite of jurors, and you can find out more about it at theTitleShiftAward.com. Next up, I also wanted to share that the Wade Institute has specialized professional learning services as well, and that is ongoing. So that's not necessarily pinned to the calendar. They've produced a lot of inquiry-based lessons and welcome all inquiries about that. And the Gulf of Maine Eco Arts Collaborative has worked with Bigelow Labs and have a current installation is Majestic Frailty. This is open to the public, 9 to 4 on weekdays up in Booth Bay. There is a potential Gommea field trip to go see this interactive exhibit, which ties together the changes in the Gulf of Maine and expresses them through art. There's been a number of schools that have participated, ranging from elementary school up through college, along with professional artists being involved in that. So now I'd like to ask if there's any other business or other events that anybody else wanted to share before we conclude our annual meeting of the membership. All right, is there, before we have our presenter, is there a motion to conclude the annual meeting of the Gommea membership?
I'll make a motion. It's Tara.
Thanks, Tara. Is there a second?
I'll second. It's Jen.
Thanks, Jen. Thanks so much, everyone. And now I would like to conclude our annual meeting of the membership for Gommea and stop sharing my screen and invite our guest, Dr. Barry Rock, to introduce himself and tell us all about his topic.
Thank you very much. I'm very impressed. That was a very efficient business meeting. I loved it. So
They're not all like that.
Of course, of course. But anyway, good evening. I'm Barry Rock. I'm a professor emeritus from the University of New Hampshire. I taught and did research in the Natural Resources Program and also the Institute for the Study of Earth, Oceans, and Space, EOS. I'm trained as a botanist and also have a master's degree in geology. And so with the last name of Rock, of course, it was kind of an obligation to get a degree in geology. Guess the other thing I wanted to mention is I love the fact that this is the Gulf of Maine Education Association, Marine Education Association. I've spent about half of my career developing K through 12 programs, all with kind of outreach, hands-on activities. And so I really appreciate the fact that Gommea is very much involved in that. So with that, let me just start by sharing my screen. Okay, hopefully you can all see that. It turns out that I have always had a very strong interest in space travel, and I'm going to show you a slide that explains that just a minute. And my research at UNH was, it involved the use of Earth orbiting satellites to monitor the health of forests primarily, and doing that from orbit. It involved a lot of field work, hands-on work with spectrometers, trying to understand best what vegetation would look like if it's healthy, but then also in the visible and the near infrared, shortwave infrared, what it would look like if it's not healthy. And then translating that into something that could be done from Earth orbit. So I love the fact that International Space Station is just STEM education in action. I mean, all of the pieces, I'd like to call it STEAM, as well as STEM, A for art. The images that we get from space, Hubble Space Telescope and that sort of thing, as well as from Earth orbiting satellites, especially including the International Space Station. That's as beautiful a type of art as you would ever see. So the nice thing about the International Space Station and this project that I'm going to tell you about tonight, it really gets students excited. And we're going to talk about the marine plastic debris problem. So some of you probably already know some of the things I'm going to be talking about, but my real question is, can we see this plastic debris from Earth orbit? And that becomes very important because if we're going to clean up the plastic trash that is in all 5 of the main ocean gyres, we need to know where it is. It doesn't stay in one place. And cleaning it up requires latitude, longitude coordinates. And so I engaged a group of 7 essentially middle school and high school programs in testing to see if we can detect this marine debris from Earth orbit. And you'll see quickly why we want to use the International Space Station. So just point out, this is me back when I was 11 years old. I'm wearing a cheesy space helmet. It turns out that my favorite TV program was called Buzz Corey Space Patrol. There was another TV program called Tom Corbett's Space Cadet. And I was all over those programs. I just absolutely loved it. So I must admit that when I was in college, I was hoping that I might become an astronaut. Well, it turns out that I never flew in space, but I worked at the Jet Propulsion Lab in Pasadena, California for about 9 years. And it was just a dream come true. Turns out that I did a lot of work, field work with spectrometers. You see on the right-hand side there, me and a technician working with a portable field spectrometer. If you look at the left-hand image, that is the Holly of Hollywood fame. This is in Southern California, and I wanted to find out if the Holly had different reflectance from a variety of other kinds of vegetation, and finding out if the vegetation was healthy using the spectrometer data, and also when it was not healthy, being able to document that from orbit. Turns out that the workhorse of my research program was the Space Shuttle Challenger. It turns out that I, working at JPL, would have an opportunity almost every week to interact with the astronauts that were flying the space shuttle, as well as other mission specialists who were on board the shuttle and conducting research. And as you may know, the astronauts were from all walks of life. I got to meet Sally Ride. I don't know if her name rings a bell for anyone, but Sally Ride was the first woman, American woman, in space. And she flew on several missions on the Space Shuttle Challenger. And I got to know her quite well. And I got to know about 10 or 12 other astronauts. We would have lunch together in the JPL cafeteria. I mean, it was a very exciting time to be involved in studying the Earth from orbit. And turns out that Sally Ride and I, when we would get together for lunch, she knew of my interest in K through 12 outreach education, and she wanted to see if I had some ideas as to how we could engage students, primarily middle school and high school, in looking at the Earth from orbit. And she came up with the idea of using something called EarthCam. And you can see in the description there that EarthCam, CAM is spelled in an odd way. It's KAM instead of CAM. And that stands for knowledge acquired by middle schoolers. Okay, so she really took to heart this idea of getting kids engaged in hands-on work. And she flew the EarthCam on the Space Shuttle Challenger. And then unfortunately, when Challenger was lost, and we'll talk a little bit about that in a minute, once the International Space Station was in orbit, then she saw to it that the EarthCam was on board the space station as well. And she has a program called EarthCam that engages students directly, getting them involved in missions flown by SpaceCam or EarthCam. We'll talk about those. That's the mission that I was interested in, was seeing if we could detect marine debris from Earth orbit. Turns out that NASA at the time had a large number of women who were involved in the astronaut program. Sally Ride's the one there on the left. Judy Resnick is next to her with the curly hair. Judy Resnick, unfortunately, was on the Challenger when Challenger was lost. And so I lost some personal friends when Challenger was lost. As you may know, the Space Shuttle has an instrument payload day. And when the doors are open, and the shuttle is over on its back, then it is looking at the Earth. You can see that radar device, that triangular feature says JPL on it. That was one of my missions. These are the astronauts who were lost when Challenger exploded. You see Judy Resnick over there in the standing off on the right-hand side. I also knew Krista McAuliffe. She was a school teacher from Concord High here in New Hampshire. She was to be the first civilian, essentially, to be in space, and her loss was devastating. I knew Mike Smith quite well, Dick Scobie. Those were all people I would have lunch with. And of course, this happened. That was in January of 1986. And this was devastating to me. I won't go into any detail there, but that is the reason I came to UNH. I would have stayed at the Jet Propulsion Lab had it not been for the loss of Challenger. It was just really difficult for me to continue working there, having lost some good friends. And so, luckily, I was able to come to the University of New Hampshire, and I came there in 1987, so just a year after Challenger was lost. Let's talk about plastics. Turns out that the development of plastics was done for a very noble reason. It turns out that in the mid 1800s, right around the Civil War, billiards was a very popular game. And all of the billiard balls were made from the ivory of elephants. And so the person, I've forgotten his name right now, but he decided he could come up with a substitute for ivory to protect the elephants. And he came up with plastics. And unfortunately, in the 1950s, 1960s, we became a throwaway society. The whole idea behind plastics, in addition to making billiard balls, was to make things cheaply and to make them so you could just throw them away. And it was presented to the American public as a convenience. You didn't have to wash that milk bottle. You could just throw it away. So what started off as kind of a noble ambition has turned into a nightmare. You may know already that plastics in the ocean can be classified as macroplastics as well as microplastics. What we see here are good examples of macroplastic. And styrofoam, wow, is that a problem? Unfortunately, it floats beautifully and becomes a real issue. About 70% of the plastic trash, the debris in the oceans is styrofoam. It turns out that microplastics are pieces of macroplastic. The wave action, exposure to sunlight causes that styrofoam to break up into smaller and smaller pieces. Anything less than 5 millimeters is microplastic. And now we have nanoplastic, where it's literally very much microscopic. But as you can see from this graphic, that microplastic is about the same size as lunch for most or a lot of marine animals. And that has become a major problem. It also turns out that depending on the kind of toothpaste you use, you may have microplastic beads that are meant to scrub your teeth. It's used in place of diatomaceous earth, which used to be a common component of toothpaste, but now it largely has been replaced by these micro beads. They're everywhere. People ask how the plastic gets into the oceans. It's not from people on board ship throwing stuff overboard. It's from monsoon rains, very heavy rains, mostly from East Asia. And what is put into landfills to begin with doesn't stay in landfills. It ends up in the streams, and those streams then end up in the ocean. So that's where all of the plastic trash is coming from. It's literally coming from you and I. This graphic is pretty amazing. If you look, there's a scuba diver here. If you see that, I mean, this is literally an island of floating plastic, and it's a mix of macroplastic, microplastic, and nanoplastic. And it is a huge problem. Turns out that the marine animals that end up eating pieces of microplastic or even macroplastic often end up dying of starvation, even though their stomachs are full. And this is an albatross chick that has died of starvation. And if you look in its belly, there's a Bic lighter, 3 different bottle caps, just all kinds of plastic trash. And of course, it's not digestible. So this is a huge problem. This is a beached whale that ended up having stomach contents that were 95% plastic. All kinds of grocery shopping bags and fraction or fragments of water bottles, etc. This just shows some of the contents, stomach contents of that whale. This is just a graphic showing you off on the left-hand side. The macroplastics become microplastics, just breaking down. The fish eat them, and then of course we eat fish. And it has been estimated that 90% of people who end up eating seafood on a regular basis have measurable amounts of plastic in their bodies. So it doesn't stay in the ocean. It turns out that there are all kinds of toxins associated with plastics. Some of them are from the plastics themselves, but the long chain hydrocarbons end up collecting a variety of toxic materials just attracted to the hydrogen bonding of the long chain hydrocarbons. So a real issue. I think we're probably all familiar with the different numbered recycling categories that we can use. And it turns out that 4 of those are highly toxic and include water bottles. I think we know that. I don't think I'm surprising anyone, hopefully not, but this has become a huge problem. In addition to ingesting the plastics, marine animals get trapped in floating debris, and this particular seal is entrapped in something called a ghost net. Ghost net has become one of the major kinds of plastic trash, and they're called ghost nets because fishing vessels that go out to catch fish use the nets to catch the fish, but those nets have taken up space in the holds of these vessels, and the owners of the vessels would rather fill their holds with fish that they can sell, and so they just simply cut the nets that they've been using to catch the fish, and they all float, and as a result become a major part of the problem. Just like icebergs, the plastic trash we see on the surface of the ocean, that's only about 10% of it. The other 90% is below the surface and is going to be an opportunity for marine animals to be trapped, like this loggerhead sea turtle. This is a dead sea turtle. the area that I've been focusing on primarily is in the North Pacific, and it's the Northeastern Pacific. I'm going to show you a graphic of that, but it has become known as the Great Pacific Garbage Patch. And you'll see the acronym GPGP representing the Great Pacific Garbage Patch. These are the gyres, the major gyres. You can see 2 of them are in the Northern Hemisphere. 3 of them are in the Southern Hemisphere. Notice that the ones in the Northern Hemisphere are turning in an opposite direction from those in the Southern Hemisphere. So all of these gyres form as the result of the Earth rotating on its axis, the tipping of to about 28 degrees off vertical, winds, all of that's involved. So that's where the Great Pacific Garbage Patch is. Turns out that Northern Pacific Garbage Patch divides into 2, the eastern and then the western off of the Philippines. So again, there's the Great Pacific Garbage Patch. A lot of my work when I was at JPL involved using the NASA C-130 aircraft. In the belly of this aircraft are all kinds of spectrometers and cameras and radiometers and radar devices. And so what I'm going to show you now is some research that was published in 2018 using images captured from this C-130 over the Great Pacific Garbage Patch. The researcher's name is Lebreton. This is a modeled prediction of concentration of the marine debris. You can see that this is essentially halfway between Los Angeles and Honolulu in Hawaii. Here is the center, if you will, of the Great Pacific Garbage Patch. And so this told me where we wanted to be looking with the International Space Station EarthCam. We wanted to be looking in this 34 degrees north and 140 degrees west. This is some of Lebreton's research, and he's looking at different things. Containers, huge containers you see on tractor trailer trucks. So the plastic isn't all just really small. Below that container on the left-hand side, you see a loose ghost net. Then over on the right-hand side, there's a bundled ghost net with plastic debris associated with it. So Lebreton got spectral data looking at that particular ghost net with some macroplastic debris in it, those bright spots. So that's a ghost net, and then you've got those other things trapped in it, including a lot of animals. And I know this is late at night, pretty boring stuff, but turns out the spectral information can identify not only that what you're seeing is plastic, but if you have the proper kind of spectrometry data, it will tell you what kind of plastic, whether it's styrofoam, polyethylene, polypropylene, etc. So this is a really exciting opportunity. And the space station has what are called hyperspectral sensors on board. Hyperspectral just means very high spectral resolution devices, in addition to the EarthCam, of course. Now, the satellites that I've made use of in my own research are mostly polar orbiting satellites. In other words, they go up and over the pole. And that's very useful. They cover the same spot on the ground every 2 weeks or so, actually every 16 days. And so if you're wanting to get precise location, latitude, longitude for the plastic, and you're using a polar orbiter, you only pass over the Great Pacific Garbage Patch once every 2 weeks. On the other hand, turns out that you can use these data as long as you're looking at coastal plastic debris. And you can see there, this is off the coast of Honduras, Latin America, and that plastic trash showed up. Perhaps you can see these little embayments here. This is Landsat data. These are river mouths. And so with a heavy rain, all of that plastic is washed out into the ocean. This is one of the activities I have the students do. They locate this. There are about 8 or 10 of these features in Landsat data that are archived. And so then you can zoom in, and that would be one of those plastic trash islands, like you saw the scuba diver in earlier. You can then have the students use a Google Earth tool that allows them to measure the perimeters of the plastic trash. And that's very easily done. If you're not already doing this with your Gulf of Maine educational activities, using Google Earth and just looking at the Gulf of Maine and measuring features like the plastic trash here. I can give you the Landsat scene for Honduras that has this. And it turns out that device on Google Earth, in addition to outlining, it tells you what the area is. And you can see that's 24 kilometers square, or almost 10 miles square. So that's a lot of plastic trash. But again, this is only for coastal. Turns out that the polar orbiters do not acquire data over the open oceans. So that's where the space station comes in. Space station is in an equatorial orbit, so it's going around the planet rather than up and over the planet. And this shows you the approximate orbital path of one overpass. You can see part of it is an overpass during the day, part of it is at night. But that space station goes over these different areas, and you can see the Great Pacific Garbage Patch with the star. It passes over several times a day. So that's a whole lot better than every 2 weeks. And so we gave it a shot. We wanted to see if this would work. This is not the Earth Cam. The Earth Cam is an automated camera on board the space station, but it is downward looking. And so I use this as an example of an astronaut with a camera. And look at that heavy telephoto lens. Well, of course, it doesn't weigh anything. Remember, you're weightless in the International Space Station. So this is one of the archived EarthCam images, and it's near Harrisburg, Pennsylvania. You can see the Susquehanna River passing through a couple of water gaps in the Appalachian Mountains. And you can see the Ridge and Valley province here with synclines, anticlines. If you're a geologist, this is a thing of beauty. So what we're going to do is look down here in the lower right-hand corner. We're going to zoom in on that interchange of interstate highways. And by looking at that, you can actually see the shadows of cars. And cars are about 2 meters, maybe 3 meters on a side. And if you're looking at a plastic island, that is spatial resolution adequate for finding the plastic debris. Okay, so as I say, we can see individual cars, so we sure as hell ought to be able to see large amounts of plastic trash. So we wanted to see if this would work. It's a bona fide experiment. No one has ever done this before other than me. And I don't get any support for doing this. I'm retired. I work cheap, And I'm very happy to be engaging students in activities that involve the space station, exploration, all of that. For those of you that are not familiar with the space station, these are all solar panels. It's how the space station gets its power. The main body of the space station is right here. This is the Russian end. It's got a Soyuz spacecraft that will return astronauts or cosmonauts to Earth. And then the rest of these are all different kinds of modules. This is a Japanese module here. Pretty interesting place, very cluttered, but pretty interesting. So if we can identify plastic trash in the ocean, what do we do about it? Well, we contact a woman named Mary Crowley. She lives in Honolulu. She has 8 different ships that she sends out to retrieve ghost nets and all of the plastic debris associated with them. She says the really difficult part of collecting the plastic trash, and especially the ghost nets, is all of the dead animals that are in it. So she said it's pretty disturbing. This is a picture of Mary Crowley. She's about my age. We've known one another for quite a while. And she wants to know where the plastic debris is located. Until we can actually do that from orbit, her best chance of finding plastic debris is having someone climb up into the crow's nest on a mast and use binoculars. And that's just not very efficient. And so if we can give her a latitude longitude coordinate, boy, that's gold mine stuff. Just look at all that trash, laundry basket. There are a couple of small refrigerators, a couple of air conditioners. It's just amazing the debris that's out there. This is another approach. They are hauling essentially kind of like seine nets and hoping to trap the plastic flow. You can see the 2 boats there. They're going to the left-hand side and picking up the plastic debris as that whole system travels. This is a shot of that actually in action. So there are a couple of ways of doing this. Then the real question is, what do we do with the plastic once we get it back? Plastic makers want to get it back so they can make more plastic. And that's just not a very good idea. Turns out that the fleece that I'm wearing tonight is made from recycled plastic water bottles. You probably knew that. There's all kinds of synthetic clothing items, nylon, rayon, etc. You could side your house with vinyl siding. That's not going to end up in the ocean. It is now being used to frame homes. And again, that makes it fairly permanent, doesn't end up in the ocean. If you've got a new car or a reasonably new car, you know that everything in that damn vehicle is made of plastic. And it lightens the load so they get better gas mileage. All of that's good from an environmental standpoint. And you're not going to toss that vehicle in the ocean. So it's good. One of the things we've been working on at the University of New Hampshire in the civil engineering program is resurfacing roads using plastic tar. And it turns out that it's far less toxic in terms of runoff. The vegetation on the sides of the roads, it's as durable, if not more durable, than tar made from petroleum products. So there are a lot of things we could do to figure out how to repurpose plastic so that it doesn't become a throwaway item. So can we see this debris from Earth orbit? Well, I have a kind of a training program for middle school and high school students where they get to tour the space station using NASA video tours. Very, very amazing. I also have access to about a 15-minute video called Plastic Seas. Very well done, kind of documents the things that I've been talking about. And then I have the students, once they know when the EarthCam mission is going to be, they have to identify where they want to look for plastic trash and send me the latitude, longitude coordinates for doing that during the next EarthCam mission. And there are about 4 EarthCam missions a year. And students know about that ahead of time and can plan, etc. Then I also just have them look locally, look in their schoolyard, find out what kind of trash they've got there and what they do with it. Very hard to recycle plastic because it doesn't go anywhere other than into the oceans. And then have them discuss their ideas about how to reduce the amount of plastic waste and maybe come up with ideas for repurposing that waste. And I'm hoping that some of you tonight will have ideas about repurposing the plastic that I didn't list in that other graphic. It also turns out that they can visit the Sally Ride EarthCam website. It's got all kinds of great student activities. It's not focused on plastic trash identification, but nonetheless. Okay, it turns out Sally Ride's EarthCam website has all of these different activities. They're very hands-on, getting to know about our Earth. Sally's hope was that students would learn about the Earth by seeing it from space. It also turns out that when the students want to look for a particular latitude, longitude coordinate for plastic, I also have them tell me what would they like to see that's local for them. And maybe it would be the Gulf of Maine and particular areas on the Gulf of Maine, Portland, Portsmouth, all of that. So it makes it relevant to the students. And then there is a wonderful backlog of Sally's favorite EarthCam images. And then they come up writing stories about the International Space Station and the EarthCam, and then what kind of STEM activities or STEAM activities on the space station they would like to know more about. And then, of course, what I would have loved as a kid, you too could be an astronaut. Okay, it turns out that the latest EarthCam mission was September 21st through 24th. And Derry, when I gave this presentation, a couple of months ago to the New Hampshire Marine docents, we didn't have results. We were hoping we'd find plastic, but tonight we got it. This is a typical EarthCam image, cloudy. I mean, it just goes without saying, if you really want a particular image from a particular spot, 90% of the time that's going to be under cloud cover. So can't look there. Sometimes it's even worse. Now, this one is really interesting because you've got some cumulus clouds over there on the left-hand side. Those are typical popcorn clouds. And then you've got cirrus clouds, high thin cirrus clouds. But then you've got this odd shape right there. Is that an anomaly? Is it an island? What is it? And we did not know what that was. So then we zoomed in with the EarthCam. And is it plastic debris? What kind of things would we want to look for? This is a fairly low resolution image. It's about 400 feet long, so it's fairly large. It's in a linear pattern. And if we go back to those cumulus clouds, notice how the wind is blowing those clouds and kind of putting them in a a linear pattern. Well, it turns out the orientation of that linear pattern of the clouds is the same as the orientation of that, what we think may be plastic debris. So now here's the latitude, longitude coordinate. As soon as I had that the day after that we thought this may well be plastic debris. I texted it to Mary Crowley, and she had a ship go out to that spot. Ta-da! I'm gonna keep you on the edge of your seats. What was it? Okay, this is a higher resolution image from EarthCam, and it turns out we can see floating macroplastic, those bright spots. There are a number of them, all like that, all down through here. And then boom, that's a ghost net. And I put a question mark there. We have found out that it is a ghost net. And Mary Crowley picked this out of the water. Can you imagine that? Huh. I was excited. I don't know if the kids were excited, but I was excited. This is just beyond my wildest imagination. And just to compare that with the Leberton image from the aircraft, it looks kind of alike. So evidence that I see that this is marine plastic, it's sharp edged. That's because of the wave activity and the wind. It's got an odd texture. Is it elongated? Yes, it's elongated. Ghost net material is very often elongated. And what we really need would be infrared spectrometry to identify that as plastic. But we did the next best thing. We had Mary Crowley go out and decide it was actually plastic debris. I have a colleague at the University of Hawaii who is a plastic debris expert. And he and I, before we got the word from Mary Crowley, it took her a week to get out here to find it. But we were debating, is it an island? Might it be sargassum, floating seaweed? But the ocean is too deep here. You've seen pictures of the sargassum forests in the oceans, and they're rooted to the ground, to the seabed. So that's not likely. And so he and I, it was a 50-50 bet. It probably is plastic, but maybe it's not. There's no island there because we have the latitude, longitude coordinates, no islands. So question is this the beginning of some really exciting stuff? And the next EarthCam mission is going to be right around December or January. And so we're going to look again. The seas will be much rougher at that time. This one in September, that's right around an equinox, and ocean currents and chop and that sort of thing are at a minimum during the equinoxes, which is interesting. I have the pleasure of telling you that this actually works. We've done it. That fact that Mary found plastic there, a plastic debris ghost nets, doesn't mean that what we imaged was that. And so the next mission, we're going to have the infrared spectrometry sensors on the space station kind of they're going to be looking at the same spot at the same time as the EarthCam. And so hopefully we will be able to get spectral data that will identify it as plastic and maybe even tell us the kind of plastic. So I didn't see anyone sleeping, so I guess that's good. Does anyone have any questions? I'm done with what I had to say. Tara, I knew you'd have a question.
It's funny. I'm thinking about drones, and if I don't know if you can hear me. Hold on. I'm thinking about just drones, and if drones could be like an intermediate stop
Yep.
on the. But
Absolutely.
yeah.
In fact, Mary's 8 ships, they have some very large drones on board. And even though I could tell her the latitude, longitude coordinate, she wanted to kind of scan the whole area, and that was done with drones. So that's exactly the technology that's being used. And these drones can have multispectral and hyperspectral spectrometers on board. Multispectral just means you've got one blue, one green, one red, one infrared. Whereas hyperspectral, like when you're hyper, I'm hyper, you got a whole lot of very narrow spectral bands. And the drones have multispectral and hyperspectral sensors. And so they will be able to go out and with artificial intelligence, they can identify using spectral peaks and valleys, whether it's plastic or not. So yeah, drones are a biggie.
Well,
Good
and when you were talking about the classroom being involved also, I was also just thinking about the fact that it might be fun for the classes to send a drone up above their school. And then, but just to do like see if you can look at these drone photos of your neighborhood or your school, and can you pick out any garbage debris type thing from those images as kind of like a local analogy.
Yeah, overflowing garbage bins. It turns out that Winnicott High School is one of the schools that was involved in this project, and they have purchased 2 drones, and they're right on the marsh. And so they're working with a graduate student of mine named Mike Ruthier, and Tara, you may know of Mike. And he's identified the spectral signatures of about 12 different kind of marsh plants. And he knows their relative location. And so the Winnicott High students fly particular areas of the marsh to see if they can pick up the spectral properties of whatever the marsh vegetation is. So yeah, I mean, the sky is the limit here.
Literally.
That wasn't meant to be a joke, but I guess it is. Any other questions?
Carol, go for it.
Okay. Well, this is fascinating. I'm not a formal educator, but I think that this is an amazing, amazing link from space down to sea. And thank you, Doctor, for explaining this to us, because I live down by the beach, and I see the International Space Station going by, and it's like, oh, what are they doing up there?
Yeah.
And now I can say, oh, I know one thing that they're doing.
Yeah.
But so I have a question about this Mary Crowley. Oh my gosh. I mean, do you like literally just text her and then she sends a ship out to the middle of the Pacific? And like, who pays for this? And whose ship is this? And like, I mean, is this an organization she's with? Like, this has to be in a very expensive undertaking to tell her where this massive garbage patch is that you suspect, and you said that you suspected it, but so it's not even a guarantee for Mary to actually get a crew and a ship to go there, pull it up, and then also dispose of it, which has, not just plastic, but debris from animal remains. So like, could you explain after you text her what happens? And is she like independently wealthy? I mean, I can't imagine that this is a inexpensive undertaking.
No, you're absolutely right, Carol. And turns out that Mary Crowley is independently wealthy, but she also has a very large multi-million-dollar grant from NOAA. And so she's being funded to do exactly this as kind of a proof of concept, demonstrating that, yeah, this can work. And Mary's biggest frustration has been, you have to look with binoculars from the mast of a ship to see this. She wanted to know specifically where this would be. And so that's how she and I got together. There is an international team of remote sensing specialists from NOAA, from NASA, from ESA, which is the European Space Agency, from JAXA, which is the Japanese Space Agency. And we meet once a week. And the focus of that group and the meetings is detecting plastic from orbit. And Mary Crowley was invited to participate in this international group about 4 years ago. That's when she and I first met. And she loves the fact that I'm engaging students in the process. And she loves the fact that we actually detected plastic. And it's not an inexpensive effort. Just think of all of the fuel oil you burn to get out to the site. And if you get there and there's no plastic, then you've dumped a whole lot of carbon dioxide into the atmosphere just getting there and then going back. And so she is very happy to fund this group of 8 vessels. 2 or 3 of them are very large, and the others are about the size of what I showed you in this presentation. And so she's doing this because she loves the ocean. She's been a sailor. She is in the Transpac, the Trans-Pacific race I don't know if it's every year or not, but she has a large 38-foot chote, that kind of a ship, sailing ship that she uses. So I don't know if this is really answering your question. What happened?
Yeah. I just want to end with a comment. How come her face is not on the cover of Time magazine as the person of the year? I mean, this is an incredible woman, as you are too, because you're giving her all of the coordinates. So yeah, this is huge. Thank you.
She is a very humble person. She would be appalled if she was invited to be on the cover of Time magazine. She's a very special person. But it's a great idea. And you're not the first to suggest it. And she just turned beet red and said, no, she'd rather die than to have that happen. So
Thank you.
yeah.
Thanks for asking, Carol. Melissa, you want to go ahead?
Yeah, hi. Can you hear me?
We can hear you.
Awesome. Yeah. So I had to tune in via phone driving home from parent-teacher conferences, and I am very interested to see how I might be able to get my high school students involved in this.
Ooh,
thank you.
Great. Are you seeing, were you able to see this graphic that any questions? Because my email is at the bottom. And my email,
yeah, so
it's rock, R-O-C-K, lowercase, dot, B for Barry, and then G for my wife, Jerry, at comcast.net. And if you send me an email, Melissa, you and I can talk about how you could get your students involved.
Thank you so much.
Great, thank you. I'm writing your name
Wonderful.
down.
Ah, great. And Teresa, you had your hand up.
Yes, thank you. Thank you for a great presentation. My question is not so much along the lines of applications in the classroom, but knowing, as we do it with more and more information over the years from the international cleanups and such, we know that there are definitely hotspots around the world where, because of infrastructure challenges, that there a lot of this debris is more and more prevalent. And are there in this work that you're doing, like identifying where we have these congregations in the water, are there applications for also identifying sources and helping with the sort of the needs and the attempts to help countries that really need a lot of help with their infrastructure and managing the plastics? And I also am a little concerned. I think more and more we're finding that there's less and less plastic recycling actually occurring, and that the cost of actually producing the raw material is much less than the recycling into composite materials. And I think in any educational program nowadays, we need to be really careful about how encouraging we are about the reuse of plastics, may I suggest? I don't know. Those are my thoughts, and I really appreciated your presentation.
Well, Teresa, thank you. And your thoughts mirror mine. The frustration is that plastics have created the throwaway society that we all live in. I grew up in the late 40s and early 50s as a 9, 10, 11-year-old. And our milk was always delivered by the milkman and in glass bottles. And once we had emptied a glass bottle, it went into a little carrier that the milkman had left. He would bring us 6 bottles. And when we were done, my mother would wash out that bottle and put it back in the basket. And when he came by to deliver more milk, he would take those glass bottles, sterilize them, and then reuse them. And coming out of World War II, I was born in 42, so I would have been 3 or 4 when the war was over. But we were very much a recycle everything, reuse everything. And I can remember when the milkman went out of business because milk was now produced by cooperatives and was available in the grocery store. Times change just dramatically. And if we could get back to that idea that we have a responsibility to kind of protect the planet and protect it in ways that are relevant to whatever it is we do. That's why I've developed these hands-on outreach activities K through 12, because if you can get a kindergartner really excited about something and they can survive the hormone rush of middle school, they're going to be very productive citizens. And so each of us can do whatever it is we can do. And so I appreciate your thoughts. Thank you very much.
Thanks.
Any
Teresa.
other questions? Looks like Cassie.
Cassie.
That was such a nice way to end it, though. I had a very specific question about Lebreton's paper, and the unknown item looks very much like a triangular mini boat sail, and I was wondering the scale of that image, if you might know.
Wow. Well, I will have to get the paper out.
Okay.
I can send you a copy of it if you'd like, but
Yes, please.
I must admit, I was just looking at the ghost net and the floating plastic debris.
I was
So-
immediately drawn to the unknown there. So I'd love to read more about it.
Cassie, that is great. That's the value of having extra eyes
I love that. It's
and
great.
fresh eyes.
And can I give you my latitude and longitude to look for something too?
You certainly can. So that is great. Thank you. I'll send you a digital version of the Leberton paper. I will also look, I'm sure, in the graphics in the diagrams, there is a scale bar, but I didn't think to include that. So
No, I'll send you a picture of what I think it might be, and you'll be interested. Thank you for a great presentation.
okay, you're welcome. Any other questions? Well, I hope most of you are informed in a way you hadn't expected about the plastic debris problem, about the idea of using Earth orbiting satellites. And we are so blessed to live at a time when all of this is available. And most of you, probably all of you, with one or two exceptions, are young enough. So you're going to be able to hopefully do something with all of this information and the technology and the scientific capabilities that we have.
It was a wonderful presentation. Thank you. And
Very welcome.
such a wonderful connection, thinking about things from space and how we can incorporate marine debris into the curriculum where it might not be sort of on the top of the agenda. It's a way to connect it in. So thank you very much.
Thank you for staying awake and staying connected.
Wonderful. Thank you again, everyone, for attending. Sorry, go ahead.
I was just going to say, are we done?
I think we're done. I'll kind of hang around, but I guess officially we are concluded. Thank you all very much for attending, and stay tuned. We thank you also for agreeing to let us share this. So our web guru will make that accessible for our members.
Great.
Thank you so much, everyone. Have a great night.